Hi everyone, today we are going to see constructional and working difference between a DC voltmeter and a AC voltmeter. Although we are discussing only the difference of AC and DC voltmeter, but the same reason is applicable for AC and DC emitters too. First we are going to go with DC voltmeter, and this is the construction. Inside we can see it looks like this. So this is permanent magnet moving coil. So in this we have two ranges. So for one range we have these two connections. This is common and this is for 300 volt, and this is common and this is for 600 volt. So that way you can connect it. You can drop the voltage according to the requirement. And this is the permanent magnet moving coil. Inside we can see two springs which are to give the controlling torque as well as for giving incoming and outgoing supply connections to the moving coil. This coil which you see is wound on a aluminium former, and that provides the eddy current damping to this coil. This moving coil is free to rotate in this periphery as per the deflection which is given due to the current flowing in this coil. Other side of coil is pivoted to a needle which is there to give the deflection on a scale. You can see how this phosphorus bronze spiral hairspring looks like. We have two such springs, one is on the other side. So you can see the moving coil again very clearly wound on a former, and this is free to rotate in this periphery, and inside you can see a permanent magnet. This part is permanent magnet and you can check it by using a metallic pin. So that is why the name is permanent magnet moving coil. Working principle of this instrument goes like this. When the instrument is connected to current circuit, the operating current will flow through the coil by using this helical springs, because helical springs provide the path for the current. Correct. So the coil will experience a torque because it is placed in the strong magnetic field of the permanent magnets, okay, which I have shown you also. So this force will be directly proportional to the current, and that is the reason there is a deflecting torque. And this deflecting torque will be experienced by this coil, and coil is also connected to the pointer, which is also on the same spindle, and we can see the deflection of the pointer on a calibrated scale, and with that we can get the reading of the voltmeter. Correct. But the problem is we cannot use permanent magnet instruments for the measurement of AC, because in AC direction is changing every half cycle. So if the direction of the current is reversed, the deflection of torque will also reverse, because the field produced by the permanent magnet does not change, but the current is changing. So in that case what will happen, it will give the direction in the deflection in the wrong direction. So it cannot be used for the AC. These permanent magnet moving coil instruments cannot be used for the AC, and they can be used only for DC, where the direction of the current is not changing. Correct. So now we will go with the AC meters, and we'll see how they look like. So we have opened up this voltmeter, which is basically a moving iron type voltmeter. This can be used on both DC and AC. Main parts are, one is this stationary coil. Inside this stationary coil we have a spindle, and in this rod we have connected a moving iron, and that moving iron is not visible, and you can also see some controlling mechanism, the helical spring, and on the spindle top we have a needle which is free to move over a scale. So the working principle of this meter is, when we connect input to this stationary coil, this stationary coil will produce a magnetic field, and this magnetic field will interact with the moving iron which is inside, and due to that a flux will be set up in that moving iron also, and that moving iron will experience a deflection torque, and that deflecting torque is passed to the needle. So what will happen in case of AC, when the field is changing its direction every half cycle, the field produced in this coil will reverse. Also the field set up in the moving iron will also reverse, and due to that what will happen, we'll find that the deflecting torque is unchanged, so that we find a unidirectional deflection in this needle, and that is the reason it can be used for both DC and AC as well.